quality assurance within the laboratory. So again, for this afternoon, we'll be discussing an introduction to quality assurance. Now, specifically and focusing now on your quality assurance and quality management within the clinical laboratory. So, by the way, have you met your laboratory professor already? Are you finished with the first lab activity? Hello. Are you finished with your first lab activity, guys? Okay, thank you so much for answering. Hello, am I back? Can you hear me now? Hello.
Yes, sir, we can hear you po.
Yes po.
Okay, thank you so much. Nawala ako, no? I don't know what happened. Biglang nawala yung, ano ko. Let me just present my screen again. Buti nakita na ko agad. Okay. There. Can you see my screen now? Hello.
Apo, sir.
Yes po.
Okay,
Yes,
thank you so
sir.
much. So again, let's proceed. No, I don't know where in what particular part I got disconnected, but let me just repeat it again. So for this afternoon, we'll be discussing laboratory quality assurance in the clinical laboratory. So hopefully you were able to have an idea already of the importance of quality, not only in the field of healthcare, but also in other fields like in your manufacturing industry and even in your service industry. So for this afternoon, our goal is for you to be able to explain, okay, for you to be able to define rather the important terms with regards to quality management system. Secondly, is for you to explain the important personalities who contributed in the field of quality management. So I'm very much aware that last meeting we had a discussion about the different pioneers, the different innovators of quality from the 1920s to the 1980s. But to be honest, even before 1920, even before Walter Shewhart first developed the statistical tool in measuring your quality, we already have a concept of quality going on already, even in the medieval times. So we will be discussing that this afternoon. Thirdly, is for you to be able to explain the different component of quality management system. Okay, the different quality management system model, and of course, last but not the least, is for you to explain the history of quality in general. Okay, in general. So now let's proceed to our first topic. Can you see this PowerPoint already on your TLC? Can I just confirm if you have a copy of this already? Don, can you just confirm if you have this on your TLC? Okay, good. Okay?
Wait lang po, sir.
Okay. Sabi nila, Ira, it's there already. So please check it na lang and then update me on the chat box. Thank you so much. If you can already access it. So for the reading guide, okay. So for the reading guide, the Continuous Quality Improvement in Healthcare, the fifth edition by Johnson and Solicito. You can see this on the TLC virtual library. So I would highly encourage you to have a copy of that one. And then we will also be using Henry's Clinical Diagnosis and Management by Laboratory Methods, the 23rd edition. Um, the authors are Macpherson and Pincus. We will be using chapter 1, pages 1 to 5 only, and chapter 10, pages 115 to 129. Okay? Pages 115 to and 129. So please make sure, everyone, that you would have a copy of this one. So I will be posting my own ebook copy of Henry's on your TLC. Okay, I will be posting it on your TLC already. And then every time na meron tayong ano, we will be giving you the reading guide. I will be giving you reading materials where you can base or where you can read in advance. Okay, where you can read in advance. So we're just trying to split the PDF. If we are not able to split the PDF, we might just give you the entire book. Only the Henrys, ha? Wala akong copy ng ebook ng CQI. You can have it on the again um in the TUA virtual library. Okay? In the TUA virtual library through your TLC. So again, moving forward, okay, now moving forward, let us now talk about quality assurance. So quality assurance, as defined by the International Organization for Standardization, or your ISO, it is the sum total of the activities aimed at achieving a required standard. Okay, at achieving a required standard. So it is very important, ladies and gentlemen, that with regards to quality, we are following a certain standard. If you can remember last meeting, we were mentioning, okay, we were mentioning that at the end of the day, okay, at the end of the day, we need to have a standard where we would be basing our quality. Okay, where we would be basing our quality. Why? Because if somebody would just come around and then say that they should be the one to be followed, they are the standard, and then everybody else followed, and eventually finding out in the middle of implementation that that particular standard that we are actually following are not even close to the ideal standards, okay, to the ideal standards, to the products or the outcomes that you want in your services or in your product. So it's very important, okay, it's very important, ladies and gentlemen, that we have a certain standard. Okay, it's very important to have a certain standard, because at the end of the day, isn't it, when we define your quality is a degree of excellence of something. So it is the degree of excellence of a particular laboratory result, the degree of excellence of a particular laboratory procedure, and how can we make sure that we are even close to that standard? Okay, how can we make sure that we are close to that standard? So to answer that, we should have we are close to that quality, rather. Um, the answer to that is to have a standard. So a standard, ladies and gentlemen, is our measure, okay, our measure that would ensure us that our test results are always accurate and are reliable. So why do we always need, okay, why do we always need naman to be, on the other hand, to always be accurate and to always have reliable results? Again, we would go back to square one into saying that our laboratory results are the basis of diagnosis and even patient management for our physicians. So again, okay, again, where does that these standards are where does this standards come from? Okay? Saan nanggagaling itong mga laboratory standards that we are talking about? So it could come from your system model like your ISO, your CLSI, which we talked about last time, or in the Philippines we also have the Department of Health, okay? The Department of Health that provides us institutional standard with regards to your laboratory. Okay, with regards to your laboratory. So, right now, alam na ninyo that you can actually get your standard from ISO, from CLSI, and even from your DOH. So now, okay, so now, why is quality important in the laboratory? Okay, why is quality important in the laboratory? And I would explain it to you over and over again by giving you this, okay? Giving you this idea that our sole purpose inside the laboratory, one of our greatest purpose inside the hospital is what? our purpose is to provide physician and other healthcare professional with informations to what? Okay, informations to what particular areas in the healthcare. So first and foremost, we are giving information for them to be able to detect a particular disease, for them to diagnose a particular disease, and not only that, we also provide them information about the predisposition of an individual to a particular disease. So what do we mean by predisposition? Predisposition means the susceptibility, the innate factors, okay, that might cause or that increases the susceptibility of an individual to a particular disease, such as, take for example, hypertension, your diabetes mellitus, and um, other diseases that has predisposing factors. Okay, that has predisposing factors. So what else? Okay, in our laboratory results, okay, our laboratory results needs to have quality because that information is being used to confirm or reject a particular diagnosis. Okay, it is used to what? It is used to confirm or reject a particular diagnosis. So take for example, Miss Ira Agustin went to the hospital and then the doctor said that she has this particular disease. Okay? The reason why, I don't know if you are familiar with the term of the Filipinos of asking another doctor for a second opinion. Okay? Why? Because they want to really make sure, okay, they want to make sure if they really have that particular disease in them. Okay? That particular disease in them. So it is very important now, okay, it is very important to have quality in your laboratory because your information, okay, the information that you are releasing from your laboratory may be used to reject or to confirm a particular diagnosis. What else? It can also be used by physicians to determine the prognosis of a particular disease. Okay, when we say prognosis of a particular disease, we're trying now to identify whether or not the prognosis of a particular patient is good or bad. Are we expecting the progress? Are we expecting the course of the disease to be improving or to be worsening as time goes by? Okay, as time goes by. So it's very important. Okay, it's very important to have quality inside the laboratory because your laboratory results will be utilized by your physicians in such purposes, okay? In such purposes. What else? Okay, number 4, your laboratory results needs to have quality because this information would guide your physician for patient management, okay? For patient management. They would know what would be the next step with your laboratory results. They will not just be basing on the signs and symptoms of your patient because at the end of the day, those signs and symptoms might actually be not specific for a particular disease. So they would be needing your laboratory result um, to either confirm if that that patient management is actually benefiting the patient, if it has even an effect to the patient or it is actually worsening the condition of your patient. And lastly, of course, for the monitoring of the efficacy of a particular therapy. So in the laboratory, we are actually performing what the test, which we call culture and sensitivity test. Okay, in the culture and sensitivity test, the main purpose of that test is to actually determine what antibiotics are actually effective to a particular bacteria. Okay, so in an ideal world, okay, in an ideal world, we should not be prescribing antibiotics immediately to our patient. So take for example, okay, take for example, mag best friend, take for example, si Mark, di ba? Kunwari, may UTI si Mark. Mark has UTI. And then the antibiotic he is taking, he cannot recommend that to Sam. Okay? He cannot recommend that to Sam. Why? Because the bacteria that might be causing UTI in Mark, okay, is different from the bacteria that might be causing the urinary tract infection to Sam. So they cannot just simply recommend a medicine, recommend an antibiotic that would treat that UTI. So they need to monitor the efficacy of your treatment. So this would also go through in your patients with tumor, with cancers. So the doctors would actually have checkups, follow-up checkup right after your treatment to check if your body is responding well, if your tumor are actually responding to the treatment or not. Okay? So in a nutshell, di ba, with what we are talking about right now, you would now see how important maintaining the quality inside your laboratory. So I guess you already have discussed about accuracy and precision. Okay, you already have discussed accuracy and precision. In the laboratory, accuracy and precision is very important. Okay, accuracy and precision is very important in maintaining the quality in the laboratory. Now, the biggest question is, now that we know that quality is very much important in the laboratory, how do we do that? How do we maintain quality inside the laboratory? How do we maintain quality um, to always be in every single process that we do? The answer to that would be your what? Your quality management. So um, quality management is what? It refers now, okay, quality management refers to the overall process used to ensure that laboratory results meet the requirements, okay? Meet the requirements for healthcare services to your patient, okay? To your patient. So, quality management, okay, like I hope you still remember the 12 elements that we discussed last time, from organization to the facilities and safety in the laboratory. So all of those 12 elements are interrelated to one another, and all of those are aspects in the laboratory that needs to be over overseen. Why do we need to do that? That is to maintain and that is to manage quality inside the laboratory. I hope you also remember that when we were talking about particular organization to quality, and not just simply directing it to that there to quality, but also maintaining and controlling that quality. How can we do that? Management. So to even emphasize the importance of quality management in the laboratory, let me give quality management is to always ensure quality. Okay, the quality management is a system which would ensure that everything in the laboratory are of good quality. They are of good quality so that when you release a particular result, when you perform a particular laboratory procedure, it it's sure, okay, you are sure that you are having the highest quality that is possible. There are some elements that may be familiar to you, but sometimes they are actually confused with one another. So the total quality management is actually an approach to quality management. Okay, quality management. I guess you already have heard of I think that was the one discussed in the laboratory last time. Are you familiar with the quality control, quality management, and quality assurance? Have you heard of those terms already? Can I see a raise of hand if it is a yes? Are you familiar with those already? Okay. So let us ask somebody, no? Let us ask somebody to differentiate that, because I'm pretty sure that you were already able to discuss that already. So let us ask Asinas. Okay, Asinas. Can you please tell us which is under which? Okay? Sino yung under sa QC, or ano ba yung arrangement nila? Okay, Miss Asinas. Hello. Hello? Can you hear me, guys? Am I on? Yes.
Ano po ulit?
Um, in the order, okay, di ba we're talking about quality management. Quality management is under QA or it is QA under quality management?
Um, Quality management is under QA po.
Can you speak louder?
Quality management is under QA po.
So QM is under QA, is that what you mean?
Yes po.
And then QC is under what?
Um, QM.
QM. Okay. So can I thank you so much Miss Asenas. Can I get another answer? Okay? Who wants to also share their answer in the class? Who wants to share? What about nandito na sila yung iba. What about Miss Kirsten Claire Chua?
Uh, for me po is QM
Hmm?
is under QA,
Hmm?
and then the quality controls are under QA naman.
Again, QM is under what?
QA.
QA. So both QM and QC. So based on your answer, both QA and QC are under uh,
QA.
QA.
Yes.
Okay? So thank you, Miss Kirsten. Who else? Okay, I cannot see who raised that. Okay, one more time. Miss Kalasin Erica Joy. What about you?
Sir, ano po, quality control is under quality assurance. Quality
And
assurance is under quality management.
okay, correct. Okay, so guys, remember that ha. Quality control is the one under QA and QA is under QM. Are you getting me? Okay, are you getting me now? So again ha, total quality management, do not be confused with this. It is an approach in, it is a system in performing or achieving your quality management. Okay, your quality management. Now, what is continuous quality improvement? Okay, so continuous, your CQI and your TQM have been the standard approaches in quality leadership in your management. So if I'm gonna show you how it looks like, okay, this is how it looks like, guys. Okay? Ay, nawala. This is how it looks like. So quality management system is the entirety of maintaining your quality within the laboratory. So under quality management is your quality assurance. So when we say quality assurance in all of this area. Okay, quality assurance in all of this area. In one area, okay, one part of quality assurance, okay, specifically in your process, okay, in the processes, in your analytical phase, in your examination phase, is your quality control. Okay, your quality control. So as you can see, quality control is just within QA, which is within QM. Okay, so I hope that's clear ha. I guess do you have a PowerPoint presentation from Mom Nell that actually um, illustrate it to you clearly. Okay? So, before talking about quality control, let's talk about quality management first. Okay? Quality management. And why is it that Sir Ganding is saying now that total quality management, okay, the TQM, is actually the ideal or the standard approach in addressing your quality management. Okay? Your quality management. Again, ladies and gentlemen, quality management is total quality management. Once again, is an approach is an approach that you apply to your quality management. Okay, you apply to quality management. So moving forward, okay, so there before, okay, before quality naman na is already been practiced in the laboratory. But when it comes to quality management, there is a traditional thinking about quality management, and there is a total quality management thinking inside the laboratory. So let us differentiate the traditional one from the TQM, or the total quality management. Okay? Before, okay, the traditional quality management systems would just simply aim to reach the acceptable quality. Okay, the acceptable quality, it actually looks like achieving just the bare minimum. Okay, the bare minimum for them to be able to say that they have quality. So take for example in Quali, what is the passing grade for Quali? Can somebody put it in the chat box para lang din ma-remind yung lahat? What is the passing rate? Passing rate for Quali. Okay. Are the two MTO1 in existence this afternoon? Hello? Okay, hello? 60% ba? Okay, it's 70%. Okay, it is 70%, guys. Okay, the passing rate for Quale is 70%. So, take for example, for a traditional thinker, okay, for traditional QM, okay, for the traditional quality management, they would just go aim to just simply get 70. Okay, they would just aim to get 70 because that is the one that is passing. Okay, passing yung 70. So what they would aim is to simply achieve 70. But for total quality management thinking, okay, for TQM, they would actually what? They would actually aim for an error-free quality. Okay, for an error-free quality. So in traditional, okay, that's already a big difference between the two. Okay, in traditional, you just aim into to achieving the minimum, okay, the minimum acceptable quality inside the laboratory. Okay, inside the laboratory. What else? In traditional thinking, they are focused on the department. Okay, so kunwari, pag section 1 lang iniisip nila. Pag section 2 lang yung iniisip nila. But in total quality management, we are not just focusing on a particular department, but we are focusing on the entire organization. Okay? We are focusing on the entire organization. If you can remember last meeting in the 12 elements, okay, in the 12 elements that we discussed, organization was included. And as you can see, we're not naming a particular section in the hospital, not even in the laboratory, that we want to focus on. Instead, we want to focus on the entirety. Again, this is what they say na sometimes there are companies na that their parts, okay, a department in a company is better than the performance of the entire company. It should not be like that. Okay, it should not be like that. Instead, the quality, okay, in each section should be summed up into the entire quality of your organization. Okay, so in TQM, we're not just focused on department, but rather on the organization. Okay? But rather on the organization. Also, to MTO1, choppy ba yung audio ko doon? Or may delay ba yung audio ko?
Sir, minsan po nagcha-choppy po once.
Pero yung like take for example kanina, when I was asking the passing rate, is it delayed or is it choppy?
Choppy po, sir.
Okay, so hopefully this will not affect the recording, ha. So again, moving forward to traditional and the total quality management. Okay, in total quality management. So in traditional thinking, they actually consider maintaining quality and achieving quality as an expense. Okay, they would say na we're just wasting money, we're just actually spending too much trying to achieve quality inside our organization. But if you are now in a TQM mindset, okay, in a total quality management thinking, you would consider you would consider quality management as a mean to lower your costs. Remember when we discussed what we discussed last time, that laboratory errors inside the laboratory cost us what? It costs us majority of the consequence would fall in your patient outcome, some of it in your time, also in your personal effort, but you would also consider there that the resources of your company, the resources of your laboratory would also be would also be affected because of those what? Because of those errors. So it is false, okay? It is not true that maintaining quality would just actually it would not cost us more. Okay? Sometimes the initial application, the initial rollout of your quality management might actually hurt your finances. But eventually, okay? But eventually, as time goes by inside your laboratory, quality would be seen not as an expense, but rather our medium in lowering down cost inside our laboratory, because you don't need to repeat time and time again a particular result. You are not wasting time, you are not wasting the effort of your personnel, and you are not wasting resources trying to correct a particular patient outcome that was erroneous. Correct? So see that with the total quality management, okay, with total quality management, we were able to lower the cost or the expenses of the clinical laboratory. Now, with regards to the worker, in traditional quality management thinking, they would always point out the error. They would always point finger with the or blame the workers who are actually performing the test. Okay, but in TQM, they would identify, they actually acknowledge that the defect is not within your worker, but it's probably within the system. Okay, it's probably within the system, which leads me now to my question: what are the three phases of your laboratory the path of workflow inside the laboratory? What are the three phases? Archie, can you please unmute your mic and answer? Agpalo, what are the three phases of the workflow inside the laboratory? Mr. Archie Agpalo. Hello? Naririnig nyo ba ako, Don?
Yes, sir. Oh,
Yes po, sir.
Okay, thank you, Don and Mark. So, Mr. Archie Agpalo, any response from you? Are you there? Hello? Archie? Okay, let's move on. Archie is not responding to me anywhere, chat or audio. So, Mark Alagon, what are the three phases of your laboratory workflow?
the three phases would be the analytical phase, and post analytical phase.
Okay, with those three phases, which phase is considered to be the the stage where most of your errors are happening or majority of your errors are happening?
Oh, that would be the oh,
Kaya mo yan.
the pre-analytical phase.
Okay, it's the pre-analytical phase. It's okay, Archie. Just fix your signal ha para you can participate on the next ano. So, with regards to that, okay, it is the pre-analytical phase. So, why am I asking that? Okay? Why am I asking that? Because there are always instances whereby an error in the laboratory is always being pointed out to a particular medical technologist doing the test inside the lab. So meaning to say, most of the time, okay, they are blaming the one performing the test. They are blaming the one who are assigned in your analytical phase. Why? Because most of the time they would assume that if an error happened, it would always be the one who was doing the test already. But if you would actually remember our discussion last time, okay, if you would remember our discussion last time, it isn't always the case. Why? Because you have your pre-analytical phase, and quality already started the moment your doctor requested for the test. The moment your doctor requested the test, that process already needs to have good quality. It needs to have good protocols so that eventually, as it moves towards the analytical and eventually the post-analytical phase, you are sure that there were no errors that was encountered. But okay, but in case that in the traditional thinking, they don't consider it that way. They always point finger to the workers who are performing the test, the actual test. But in reality, okay, in the TQM thinking, we would actually identify. Remember the root cause analysis. We would identify what area or what part of the system was actually the source of error. Is it really the examination or the analytical phase, or is it the procedures prior to that? Okay, so that would now be the patient preparation. How did you instructed your patient? How did you collected the sample? How did you transported the sample? And how did you evaluated the sample for acceptance? So all of those are under your TQM. Okay, under your TQM. So in the traditional one, the worker are management controlled. So they are like robots and puppets that when the management say, okay, do this, they would do that. When the management say, do this, they would do that again. If the management say, okay, refrain from doing this, they won't do that. Okay? Unlike in the TQM thinking, remember, okay, personnel is one of the essential element in quality management there, and they would want to empower the workers. Okay, they would want to empower the workers. Traditional thinking, okay, in the traditional QM, your workers would look like this. 15 minutes before 5 p.m., they are already waiting, they are already clearing out their tables, they're already lining up, okay? Lining up to your bonding clock or your biometrics so that they would now log out of the company and would immediately go home. While on the other hand, an empowered worker would actually not be doing that. They actually have that sense of accountability and that sense of ownership inside your laboratory, inside your organization. Okay? And if you would actually be weighing which is better, obviously the one better is actually an empowered worker. Why? Because as the owner, take for example, as part of the admin of a particular clinical laboratory, you could you could actually have confidence and have the trust that your workers are actually thinking of are also thinking about the welfare of the entire company and not just simply earning money out of it. Okay, so that is very important. Okay, that is very important. Aside from that, in the traditional thinking, we are so much fond of the status quo. So for as long as we perform it, okay, for as long as we get the job completed, that's fine with us. But in TQM, here comes now your continuous quality improvement. Okay, in TQM, we are always looking for opportunities for improvement. We always look for an area where we can improve our product, where we can improve our services, where we can improve our laboratory results. And that's the ideal one. That's the TQM thinking. We would always want to improve the things that we are doing inside the laboratory. Okay? So, moving forward, What else? Okay, the traditional thinking. Okay, the traditional thinking, they would always manage according to intuition. So they would always manage according to their gut feelings, according to their emotions, according to what currently they are feeling at that particular moment. But in your TQM, okay, in your TQM, they would actually be managing by facts. Okay, they have a set of objectives. They have studies that would back up the next step that they will be doing. While the traditional thinking, okay, what else? In the traditional thinking, they say that quality is intangible. It's an abstract concept. That's why they don't even know how to measure quality inside the laboratory. And if that's the case, you don't even know if there is even quality inside in your clinical lab if your quality is intangible. Unlike in your TQM, quality is very much well defined. You have a set of criteria laid out, okay? You have a set of criteria properly laid out, and you also have a set of goal and objectives that are properly laid out for you to be able to check that there is actually quality inside your clinical laboratory. Okay, so in the traditional thinking, okay, it is a we versus they relationship. So there is already a competition within your organization. But in TQM, it's not like that. Okay? It's an us relationship. May tayo sa TQM. Okay? You think about not just yourself, not just your own group, but the welfare of the entirety of your clinical laboratory. Okay? Merong tayo sa TQM. Alright? So in traditional thinking, okay, you always think of the end process. You are end process focused. What you think about is always the what. You always think about the product. But in TQM, you are system focused. What do we mean by that? You focus on the actual process. Why? Because at the end of the day, di ba? At the end of the day, a lot of people kasi are very much focused on getting to the end without even thinking of the process, the quality of the process, the person that they are becoming during the process. So it is very important that in TQM we focus on the process instead of just focusing on the product. Because in traditional QM, okay, in traditional QM, they always think of the product, no matter how they did it along the way, no matter what the process is, for as long as the product will be um this, then they will be happy with that already. The problem with that is that, sabi nga natin, success is always predictable. Okay? Success is always predictable. So, if you achieve success for the first time and you cannot repeat it, okay? Um, you are actually only focusing on the end product. Okay? You are only focusing on the product. So, sabi nga natin, di ba? In your total quality management thinking, system process, you focus on the process and you believe that success is repeatable. You can repeat success by focusing not on the product, but focusing on the process. You focus that every single thing on the process would actually lead you to the desired product that you would want at the end of the day. Okay? At the end of the day. So it is very important for you to make sure of that. And lastly, okay, in the traditional QM thinking, we are a reactive system. Okay, what do we mean by reactive system? If they are problem, you would solve the problem. If there are scarcity in the supply, you would address that. If there are fights among your employee, you would address that. What do we mean by reactive? You only react, or you only solve a problem when they arise. Okay? So you don't really are a visionary leader. You don't even have that proactive system with you. In TQM, they do have that. They are proactive. So what do you mean by proactive? Even before the problem arises, they already thought about it. Okay? Even before a particular scenario arises inside the laboratory, they already thought about what they would do and how they would prevent and actually solve resolve all of those problems that might arise. That's what you mean by proactive, okay? That's what you mean by proactive. And as students, okay, which would you prefer to be choosing? The traditional one or the TQM? Can I hear it from the chat box? What in the in the comparison that we had, would you be a traditional one or a TQM? Okay? So I hope everybody would be answering the second one, the TQM. Okay? So hopefully everybody would be choosing the TQM, correct? Why? Because you don't want to be somebody who would just be reacting after seeing a failing grade in the midterms. But you would actually be a proactive one that would be monitoring your progress in the course of this subject and eventually um, improving, okay, continuously improving your performance as time goes by. Okay? And by the way, okay, I have locked the Google Meet. So everyone who went out of the Google Meet would have to be admitted by me. So I would know who are those na nawawala at hindi na bumabalik. Okay? I am, o gaya niyan, si Kaasi, ngayon lang babalik. Okay? So, I am monitoring who are those coming out and coming in of the Google Meet. Okay? So, moving forward, let's now differentiate TQM and CQI. Again ha, TQM, okay, TQM is a system of ensuring quality management. Again, so TQM is a system approach that focuses on teams, processes, statistics, your facts, the delivery of your service and your products that meet or even exceed your customers' expectation. In CQI, okay, CQI is an element of your TQM that strives to continually improve the practices and not just meet the established standard, not just meet the status quo, but to even improve and surpass that even more. All right. So with regards to TQM, okay, and CQI, I hope that's clear already, ha. CQI is not a different system that we use in approaching quality management. Rather, your CQI is a component of your TQM, and TQM is a system approach that we use to address quality management inside the laboratory. Again, what is the use of your quality management? The use of your quality management is in maintaining and directing your clinical laboratory towards a required standard, towards quality. Okay? So now, in the laboratory, what we are very much acquainted of in doing is your quality control. Okay, your quality control. Every single medical technologist would be performing quality control. The reality is, not every medical technologist, okay, would be participating in the higher forms of quality assurance because they would not be always part of the admin, di ba? Meron naman yung mga, mga simpleng medical technologists that are working inside the laboratory. And one thing is for sure, every single medical technology should know how to perform your quality control. Okay? Your quality control. So quality control is said to be a system of ensuring accuracy and precision in the laboratory by including quality control reagents. Again, it is a system of ensuring accuracy and precision in the laboratory by ensuring, okay, by including quality control reagents, which lead me to my question this afternoon. What is precision and what is accuracy? What is precision and what is accuracy? I want to hear it from um I want to hear it from Kat. Okay, Miss Arinas. Arinas, what is precision and what is accuracy?
Sir,
Yes.
naririnig niyo na po ako.
Yeah, you're audible na.
Accuracy po yung results are near to the target value.
Mm.
Then yung precision po is yung measurement po of the results are comparable with another.
Comparable with one another. Okay,
Yes,
correct.
po.
Thank you so much. Okay? So, It's good that you got it on the first definition. Now, everybody, I want you to look at the screen. I'll be presenting something on the screen, and I want you to tell me if it is accurate or if it is precise. Okay? I want you to tell me if it is accurate or if it is precise. Okay? So I am just joining the Google Meet right now. So let me share my screen, everybody. Okay? Can everybody see my screen now? The other screen that I am presenting.
Yes po.
Okay? Okay, so not here. So okay, so here. Okay? So we defined accuracy, sabi nga ni Kat kanina, accuracy as the closeness to the true value. Okay? To the true value. While precision, okay, is the nearness, okay, or the somehow the closeness, okay? Careful if you're using closeness. Closeness of the different values. Now, let me ask you this question. If I have 5 sets, okay, 5 sets of data, and I said that all of them, okay, I said that all of them are accurate. Is it automatically true that all of these data are also precise? If all the data are accurate, if all the data are accurate, will it automatically mean that they are also precise? Can I see an answer on the chat box? If we say na lahat sila, okay, may nag-yes, may nag-no, that's interesting, okay? Okay, that's interesting. So, everybody answered, most of you answered yes, and some of you answered no. Let's ask representatives from those answers. So, let's go with Joanna. You said yes. So meaning your answer is yes, meaning if it is accurate, automatically, if the 5 datasets are accurate, automatically they are also precise. Why did you say so, Miss Agulto Joanna?
Kasi sir, 'di ba yung definition, for me po, yung definition, 'di ba yung definition ng accuracy is closeness to the true value. So, when the 5 dataset is all accurate, it means they are almost on the same value or target value.
Okay, that is very well explained. Thank you so much. But hindi ko pa naman sinasabing yun yung tama. But let us now hear it from people who said no. So we have Arnaldo, we have Mariel, we have Jake, and we have Bayao. I want to hear it from Jake. Deo, Mr. Cadillo, why did you say na no sir, hindi, that's not true. Not because it's accurate, it doesn't always necessarily mean it is precise. What can you please justify your answer, Jake?
Siguro po sir sa pagkaintindi ko po, if accurate, kung gano'n na yung close to the near value, baka yung iba namang sets is iba-iba yung true value nila at hindi yun nagiging near with the other variables po.
Okay.
Magulo po.
Okay, sige. Na-gets ko naman. Okay? So thank you for that. But what we're talking about kasi, okay, people who answered no, we're talking only about the 5 datasets. So this is how it looks like. Okay, if the 5 dataset, I have 5 data. 1, 2, 3, 4, 5. And this is the target value, the inner circle. This is accurate because they are all within the target value. Now, tell me, okay, tell me class, are these data also precise? Yes or no? Now on the chat box, everybody participate. Are these data on the inner circle precise? Are they precise? Okay? Yes po, yes po. Okay, your answer. Okay, ladies and gentlemen. Your answer should be what? Your answer should be yes. May nakita akong isang no. Okay? Miss Amira, I'm interested. Why did you say no?
Yung definition po kasi ng precision is, 'di ba, the closeness to one another. So,
Hmm.
it's relative. And I think that true precision requires very small measurements. So, dun po siguro sa technicality na yun. Pero if hindi naman po, I mean, ayun po. Sa technicality na dapat very small measurements yung gagamitin.
Okay,
That's
so
why I said no po.
so if we're gonna go to the technicalities that you are talking about, Miss Amira, so how can you relate now? What would be your measure of precision then? How can you measure precision so that you can say na they should be close to one another?
I think po dapat may separate like standard po tayo to 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 justify what is precision for a certain result. So if kunwari sasabihin natin na precise kung yung differences nila with each other are 5 centimeters, edi that's what we will follow po, in my opinion.
Okay. So thank you for sharing your sharing your point. But in this particular in this particular set of data that we are talking about, ladies and gentlemen, always remember that when your data are all accurate, when we say that they are all accurate, they are always precise. Okay? They are always precise. Why? Because they are technically close to one another already. Why? Because they are all within the true value. They are all within the true value. So, with what we are talking about, the relativity of how close they should be from one another, okay? How close they should be from one another is not actually subjective, but may objective naman tayo doon. Meron naman tayong measure doon. So, your precision, oops, nawala. Your precision, okay, ladies and gentlemen, can be measured through your SD. Okay, you have your standard deviation there. Okay, you have your standard deviation. So the higher the SD, the lower the precision. Okay, the lower the precision. So the lower the SD, on the other hand, the higher the precision. So we are assuming, okay, ladies and gentlemen, we are assuming that those values that are accurate are those that are having low SD, meaning to say they are highly precise. They are close to one another. Okay, so I hope that cleared it out, huh? But again, okay, what I'm just trying to say here is that all values that are always accurate, are also precise. Okay? So now tell me, are all on the other hand, 'di ba? On the other hand, kabaliktaran naman, not all that are precise. Okay, to take for example, we say that these data sets are precise to one another. But question, are they accurate? This data set here, the red ones, are they accurate? Yes or no? Okay? So the answer here should be no, okay? So these are yes, there are precise, but they are not accurate. Are you getting my point there? If we're just taking it on the distance of one data from the other, they are precise. But if we're gonna talk about accuracy, that's another story for another time. So what I'm trying to say here is that accuracy and precision, okay, accuracy and precision should always be checked inside your laboratory, because not because that they are precise, automatically they are already accurate. Okay? No, no. But if you say that they are accurate, okay? If we say that they are accurate, automatically, okay, they are also precise. Okay? They are also precise. The data set that we are pertaining, okay, are also precise. A numerical example would be like this. Okay? So take for example, the true value is 100. The data that you gathered, the 5 data set that we're talking about are 97, 98, 99, 99.5, 100. These are data that are what? They are accurate. Okay, they are accurate. And they are also precise. Okay? They are also precise. Now, on the other hand, we can also have a data set that are precise but inaccurate. Okay? An example of that would be what? Okay? An example of that would be what? 20, 21, 22, 20.5, 21.1. Okay? These data are close to one another. These data are precise, but these data are inaccurate. Nagigets po ba ako? Are we clear? Hello? Are we clear? Can I see a raise of hand if we're clear? So, there are cases where all your data, okay, all your data are precise like this one, but not necessarily they are accurate. So it's very important na in the laboratory, we check those two. Okay? We check those two. Question, your precision is also known or also called as your what? Your precision is also called your precision is also called your what? Anyone from the class? Your precision is also known as your reproducibility inside your laboratory. Okay? Precision is also known as reproducibility inside your laboratory. Now, okay? So in quality control, what we are ensuring, what we are trying to always check would be your accuracy and your precision. And how do we do that? By measuring your quality control reagent. Now, which lead me to my next question. And I want you guys to remember this until we meet each other again next semester. Okay? Again, until next semester. What is the universal color? Okay, what is the universal color of your QC material or your quality control materials, or in general, in its simplest form? What is the color, the universal color of your control? Okay, what is the universal color of your control? Any guess? Was it mentioned in the lab? May nagsabi green, may nagsabi black. Okay, what is the universal color of your quality control reagents? Let me define to you first what are quality control. Okay, what are quality control reagents, or what are control? Controls, okay? Controls are being used in the laboratory, okay? Again, di ba? Controls are being used in the laboratory to ensure that analytical results are correct and the testing are acceptable. So how do we define your quality control? They resemble your patient sample. So sabi, kamukha daw siya ng mga sample ng tao. So which leads me now to my question. What is the universal color of your controls or your quality control reagents? The answer would be, okay, question, what is the color of your plasma in your serum? Anatomy, circulatory system. When you centrifuge a blood, what is the color? It is what? Yellow. Okay? It is colored yellow. Correct. So always remember, ladies and gentlemen, that your quality control reagent, okay, your quality control reagent should resemble your patient sample. It should resemble patient sample. Dapat kamukha ng patient sample. Because what we're trying to check here is that if they are actually able to detect that particular level. So take for example, I have my normal control, okay? My normal control contains 70 to 100 milligrams of your glucose, okay, of my glucose. If my machine, okay, if my reagents and my medtech, okay, are all in control or are all in good quality, when they measure my normal control, okay, when they measure the normal control, they should get a value within 70 to 100. Nagigets po ako? They should get a value within 70 to 100. Meaning to say, whatever is the measurement, these are like predetermined values already of your control. These are like standards na dapat pag alam, we can say na this particular machine is effective if they are able to measure a particular sample within this range. Nagigets ba ako? Are we clear? Hello, are we clear? I want honest answers ha, kung clear ba or hindi, so that we would know if we can move on or we should repeat what we are talking about. Are we clear? Hello?
Yes po, sir.
No, okay. Let me repeat it again ha. Let me repeat it again. So, your controls, sabi natin, your controls should resemble your what? It should resemble your patient sample. Sir, why are controls important? Let me just share my screen. Okay? So, we have your control here. Okay, gawin natin color yellow para cute. Okay? So, now, we have here your controls. Okay? Your controls, okay? Your controls are colored yellow. Why? Because they always resemble, okay? They resemble patient sample. Okay? They resemble patient sample. Your control are like their levels, okay? Or measurements are already known. Okay? Yung levels nila are already known. So take for example, I have a glucose control. Okay? A glucose control which is normal. Sabihin natin normal muna. Normal control. So your control, ideally, the the predetermined value of this is 70 to 100 milligrams per deciliter. Okay? Remember what we said last time, that you do quality control before or after running patient sample. Can I see it on the chat box? You run your control before or after. Okay, good. We're all on the same page. Before running. Why do you run it before? Why do you run it before? Anyone? Why do you run it before testing? Why do we run it before testing? I want to hear it from Samantha. Why do we run it before testing the sample of your patients? Why does control comes before your patient sample? Why? What is the purpose?
Sir, sorry. The reason why we run it before is to
Is to what?
to test the quality of the
Test the quality of
the sample.
Is it the sample immediately? Isn't it you're gonna do it before?
Sir?
Isn't it you are gonna perform it beforehand? Okay, you're gonna run the control before the sample. So what are we trying to check? What are we trying to determine there? The quality of your what?
Reagent?
The quality of your reagent? Correct. Just go. Reagent, aside from your reagents.
Your machine.
Your machine. Okay. And aside from that,
the personnel.
the personnel. Correct. Thank you so much, Sam. Okay. So guys, ganito ha. Okay, let's go until the top. So you have your controls. Your controls are the one that you use in your QC. Okay? Why are controls important? Controls are important because they are like your standards. Okay? So they resemble patient sample. That's why they are colored yellow. Okay? And this control has a predetermined or a known measurement already. We know the measurement already of this control. An example of that is a glucose control, which is normal. And the known levels of glucose within it should be within 70 to 100. Okay? Should be within 70 to 100. Most of the time, this is how it looks like. Just to give you an actual value of a particular, I don't know, a particular control, it would actually be like this. Okay? The value would be, most of the time, the value would be 100 plus minus 5 milligrams per deciliter. So what do we mean by that? The value that I should be getting should be within 95 to what? 105. Okay, the value that I should be getting out of the control is 95 to 105. Now, according to Sam, which is very correct, you run it, okay, before you run your patient sample. Why? Because you want to check the quality of your reagent, of your machine, and also the competency of your what? Of your personnel. Now, okay? Now, so now that we have determined its purpose, okay, its purpose, take for example, okay, I was able to measure, sabi natin, di ba, dapat 95 to 105. Like for example, I was able to measure 99 mg per dl. So, is it within control? Is it within control? Yes or no? Can I see it on the chat box? Is it within control? Yes. So, if your answer is yes, if it is within control, meaning to say the reagent is working perfectly, the machine is working fine, and the personnel is doing well in its procedure. Are we clear? Hello, are we clear now? Now, what about if meaning to say if I got 99, meaning to say it's within, then I can proceed to running my sample already. Okay, I can proceed with testing my samples. But what about, sabi natin, di ba, it is 95 to 105 milligrams per deciliter, and then what you were able to measure was only 70 milligrams per deciliter. Is it acceptable or not? Acceptable or unacceptable? Is the 70 milligrams per deciliter acceptable or not acceptable? Can I see it on the chat box? Okay, no, unacceptable, unacceptable, correct. So, this 70, okay, if in case you measured 70, then there is a problem. A problem that may probably within your reagent, in your machine, or most probably even in your personnel. Nakukuha tayo? Why is control very important? Okay? Why is control very important? So, again, it would give us now, okay, it would ensure us na the machine are giving highest accuracy, and also that this machine are very much reliable, or they are precise. Okay? So that is very important inside the laboratory. Okay? That is very important inside the laboratory. Now, okay? Are we clear? Can I see a raise of hands if we're clear now? Hello? Can I see a raise of hand if we're clear? Okay, thank you so much. So guys, please remember that, no, because this is already the foundation when we discuss quality control on the 22nd to 26th of February. So 22 to 26 yun yung topic natin. So hopefully you'll be able to understand that. Not even 22 to 26 baka nga next week yun na yung topics natin. All right? So moving forward, again, your quality control is just a component of your QA, and your QA is just a component of your quality management. Now, some important terms before we take a short break and then return back for a quick presentation later of the history. So, important terms that I want you to remember is number one, of course, your accuracy and your precision. Guys, do not get confused between the two, ha? So the accuracy is the nearness or the closeness of the measured value or the assayed value to your target value. Okay? On the other hand, what is precision? Precision is the ability of an analytical method to repeat results on the same sample that agree with one another. Another way of describing your precision is actually, if we're gonna be ano no, if we're gonna paraphrase it, it's also an nearness, okay? Nearness, not of the value to the target value, but the nearness or the closeness of the values to one another. Okay? The closeness of your value to one another. Do they agree with one another? Are they close, or they are very much similar to one another, or they are very much far, they are very different from one another? So that again is very important for you to remember. Aside from that, just like what I mentioned when discussing precision and accuracy, guys, okay, I want you to write this down. Okay, I want you to write this down, that when it comes to your precision, okay, when it comes to your precision and standard deviation, their relationship is what? Their relationship is inversely proportional. Let me repeat that again. The relationship between your precision and accurate, the relationship between your precision and your standard deviation are always inversely proportional. Okay, they are inversely proportional. So the higher the precision, the lower the standard deviation. Meaning to say, the more precise the value, the the smaller the distance is of the data from one another. If the data are now imprecise, okay, if the data are imprecise, the standard deviation or the distance from of one data from the other is greater. Are we clear? Hello, are we clear? Can I see a raise of hand if you were able to jot that down? Hello? Okay. And another thing before we move on, I want you also to remember later, kasi pag-uusapan natin yung descriptive and statistics, your coefficient of variation is your index of precision. Babalikan ko na lang yan later when we go to the next topic. Okay? So, again, standard deviation and coefficient of variation. Paalala nyo sa akin later. Okay? So, again, with regards to quality management and quality control, let's just differentiate one from the other. Your quality management is the overall process, okay, used to ensure that your laboratory results meet the requirements for healthcare services to your patient. On the other hand, your quality control is just a system within your QA, okay, that ensures your accuracy and your precision, okay, using your control reagents, okay, using your control reagents. So I think we're just gonna take this the history of quality quickly. So remember that during the last time we did discuss about the pioneer, like your Schuhart, Galvin, Duran, and Demings, that were innovators of quality. But even before that, we can date quality can be dated back during the medieval guilds, okay, during the medieval period. So during the medieval quality management, during the medieval times, is seen in your craftsmen, okay. So your craftsmen would actually have organized unions, which we call guilds, okay. They organize guilds, which are what, which are like an association, okay. These are association that would actually oversee the quality, or yeah, the quality of their products or their crafts. So yung mga ginagawa nila is actually being monitored by guilds. So craftsman during the medieval period would include inspection marks, okay, or a master craftsman mark that would actually serve as a proof of quality for customers throughout the medieval Europe. So during that time, okay, during that time, they actually have a symbol or a sign that when you see it in a particular product, you would automatically know that that particular product is of good quality. Kapag wala yung mark na yon, we can nobody would be buying that, or nobody would be purchasing that, because that is a substandard. That is um a substandard product. Okay? So, even before that, they don't know na quality management would be quality management as we know it now. During that time, they actually are having that. Why? Because they want to make sure that their product have the same quality. So that craftsman, okay, would ensure that the quality of their product is always there, and their customers would always be buying from them. Okay? And their customers would always be um, patronizing their products. So quality management started even before, okay, even before the Industrial Revolution. Now, what does Industrial Revolution did to quality? Okay, so during the Industrial Revolution, there are three distinct happening that took place. So we have the we have the craftsman, we have the factory system, and we also have the Taylor system that was founded by Frederick Taylor. So what happened there? So remember, okay, during the craftsman era, they are actually maintaining their quality. Okay, master maintained a form of quality by inspecting their goods before selling it. Okay, before selling it. So they make sure that it is perfect, it is well made before they send it for selling. So that is during the craftsman, okay? During the craftsman era. And then comes now your factory system. Your factory system, okay, the craftsmen who are doing this became now the factory worker. So shop owners became the supervisors for your quality. Okay, supervisors for your quality. And during this time, what happened is that um oops, nawala. Okay, during this time, okay, during the factory system, they started to increase now, okay, they it started now to increase the production. Now, the craftsman are the one that creates the product, and then the supervisors are the shop owners. So they check the product first before delivering it to the market, before releasing it to the market. But not until the Taylor system. Okay, during the Taylor system, it was actually developed by Frederick W. Taylor. His main goal is to increase productivity. Okay, his goal is to increase productivity without increasing the number of skilled craftsmen. Okay? So wala siyang pakialam sa number ng gagawa. So take for example, they need to increase productivity. They need to produce 1,000 take for example, 1,000 goblet, and there are only one craftsman who would do that. Okay? And because of that desire to increase productivity without increasing the number of craftsmen, what happened is that your quality now has been compromised. Why? Quality has been compromised because, of course, di ba, 1,000 goblets, then one person would only be doing that. Okay? They didn't know the idea of delegation during that time. So, because of the Taylor system, quality began to be compromised. Okay? It began to be compromised. That is the reason why, okay, in the 20th century, they came up now with an idea of including quality in the process. So including quality in the process. So a process now is defined as a group of activity that takes an input, okay, adds value to it, and then provides an output. So what are we trying to say here? They included the checking of your quality within the process. Okay, they included the checking of your quality within the process. And this is also the very same time when Walter Schuhart developed now your statistical tool in measuring your quality. And even up to this day, ladies and gentlemen, the Schuhart um, the Schuhart chart or the control chart became now the foundation of all the modern day quality tool that we are using. So in the laboratory right now, the Schuhart Levy-Jennings chart are still being used by medical technologists. Okay, and in your laboratory, I think on your third laboratory exercise, you will be doing your own quality control charts, and not just simply doing your own quality control charts, but you would now start to learn how to interpret those quality control chart. When would you be able to say that it is acceptable, it is unacceptable, we have quality, we do not have unacceptable quality? So you would be able to know that already. So that was Walter Schuhart. Okay? In the 20th century, they included quality in the process, and they now had a statistical, a more objective tool in identifying quality. Not just merely a subjective inspection, but rather a um, objective criteria on when to say it is good quality or not. Now, after that, okay, comes now total quality, okay, in America. Total quality, okay, quality management did not start or did not fully was not fully embraced by the America, okay, by the Americans. So um during this time, okay, Edwards Deming and Joseph M. Juran noticed that Japanese has their total quality approach. Okay, the Japanese analyzed that quality management doesn't always have to come with your product, but what they did is an overhaul of their entire organization, of their entire product. This is the reason why even up to this day, 'di ba? Even up to this day, if a product is known to come from Japan, okay, if that product is manufactured in Japan, you know that it is high quality product. Okay? These are high quality product. Why? Because way back before, they have already inculcated down to their culture and DNA that everything they do should be in good quality. They don't just do a particular product just for the sake of having a product and sending it into the market just to gain profit. They are not like that. Okay? They are really concerned with the quality of their products. Okay? So Edward Demings and Joseph Juran introduced that type of total quality approach in the America. Again, it was not fully embraced at that time. Okay, it was not fully embraced by that time. But later on, eventually, when they saw that the Japan's manufacturing industry is starting to increase because of that total quality approach, okay, the Americans now started to adopt your total quality management. So this is now the time where organizational adoption of total quality management started. And in year 1987, okay, in year 1987, the Americans now was able to have a series of quality management standards such as your ISO 9000, okay? Your ISO 9000. So the different documents that we talked about last time, so those are actually included as well. So to wrap it up, okay, to wrap it up, now in the 21st century, so we have your Malcolm Baldrige National Quality Award that has added education and healthcare to its original category. So before, okay, before, your quality management is very much known in your manufacturing industry, in your small businesses, in your service industry, because they are the one that actually are very much concerned with the customers feedback, um customer satisfaction. Now, it has been now education and even your healthcare are also added. They're even pushing that the adoption of your quality management protocols could also be applied now to your non-profit organization. Okay, so that everything would also be standardized. Aside from that, okay, quality now has moved beyond manufacturing sector. It's not just in the manufacturing sector anymore, but also in your healthcare and education, and even in your government. So now, quality function deployment in the 21st century, at the same time, okay, Dr. Yoji Akao also developed your quality function deployment. Okay, quality function deployment. So it is a process of focusing on the customer wants and need in the design or redesign of your product. So remember that sometimes, di ba, a particular product, mapapansin nyo din that a particular product would first be given to certain people for them to review it, for them to assess it, for them to check the quality of the product before really releasing it to your to the market. Okay, so why do we have certain things like that? That is quality function deployment. Why? Because they want to um, check first the customer's wants and need before redesigning and designing a particular product. The cameras that we have right now, the smartphones that we have right now, they have all of those specs and other they all have those specifications. Why? Because that is what the customer wants and that is what the customer needs. Okay, so they want a better camera, so manufacturing company would start now to create camera, would create now smartphones with better camera. In the healthcare, let's focus on the healthcare. Take for example, ito no, in the clinical laboratory, we have different packages. Okay, we have the liver function package that when a particular patient come in into the laboratory, all of the tests would be done to them. Why did we craft our test to be like that? Because that is what the customer need. That is what the customer want. They want that they have a certain package that would actually be discounted. Okay? Nagigets po tayo. So take for example, nagtitinda kunwari ng cookies si Jonas. Okay? Cookies ni Jonas. Okay? Take for example, Jonas has a product. Okay? And then he was selling it to all your class, okay? Your classmates. So O1 will be tasting it. And then some would be saying, Jonas, I want a cookies with raisin. Okay? Then Miss Amira would say, I want a cookies that has a dark chocolate flavor. And then people would now add up their input to Jonas. Now, the next time that Jonas would be releasing a product, meron na yang cookies with raisin, cookies that are dark chocolates, cookies that are red velvet. Are you getting my point with quality function deployment? Okay? You adjust your product according to your customer needs and wants. Okay? So that is not just applicable in your manufacturing, but also in your healthcare. Aside from that, in the 21st century, okay, one very distinct development in quality was also the development of your Six Sigma. Okay, the Six Sigma is a methodology developed by Motorola, and its goal is to actually improve its business processes by minimizing defect. We'll be having a separate discussion about Six Sigma and Lean system in the coming days, but here, okay, your Six Sigma was developed by Motorola, an electronic company. But did you know that Six Sigma is also being applied now to the clinical laboratory? That's how good the systems of quality are. Okay, they are not just applicable to one industry, but also to other industries as well. Now, moving forward, we also have, of course, we also have your ISO 9000 which was developed in 2000. So again, your ISO 9000 series of 2000 was actually focused, or it gave emphasis to your customer satisfaction. Okay, to your customer satisfaction. And aside from that, okay, in 2015, your ISO 9001 standard included risk management. So I hope you would underline customer satisfaction and risk assessment. That is the overall adjustments or emphasis of that particular document. So in 9000, customer satisfaction, your 9001 included now your risk management. So that is it actually for our quality assurance in the history of quality in general. We will still be continuing with our discussion. Okay, we will still be continuing with our discussion. So do you have any questions or clarification? You can raise your hand. You can make use of the chat box for your questions.